The night sky is endlessly vast. For anyone pointing a telescope upward, the search for the most beautiful cosmic target feels incredibly subjective. But out in the field, you don't have infinite time to browse. Finding that perfect shot is strictly limited by the hours of true darkness available before dawn. Add in the constant threat of cloud cover, atmospheric turbulence, and the heavy gear required to capture deep space, and every single observing session becomes a costly investment. Looking at a wide field view like this, two celebrated targets constantly compete for your precious eyepiece time: the Whirlpool galaxy and the Sombrero galaxy. Choosing between them forces a specific dilemma. You must decide whether to capture dynamic structural interaction or stark visual symmetry. To maximize the return on your night, you must look past the subjective idea of beauty and understand the underlying structural reality of what you are aiming at. Let's start with the Whirlpool galaxy, M51. It sits roughly 23 million light-years away in the constellation Canes Venatici. Its rival is the Sombrero galaxy, M104. It is located 28 million light-years away on the edge of the Virgo cluster. This comparison table tracks their baseline profiles. The Whirlpool is viewed face-on, exposing glowing starburst arms. The Sombrero is tilted edge-on, presenting a sharp, dark dust lane. Their classifications guarantee completely different outputs. M51 is a grand design spiral, while M104 is an unbarred spiral. These baseline data points show M51 and M104 represent completely opposite ends of the observational spectrum. We can map these targets on a quadrant chart to see what they offer. The x-axis tracks viewing orientation from face-on to edge-on. The y-axis tracks structural focus, from internal details to symmetry. The Whirlpool galaxy lands precisely here in the face-on internal details quadrant. Looking at M51, the defining feature of this quadrant is obvious. You only get these incredibly well-defined arms and swirling brown dust from a top-down angle. The trade-off is that resolving these faint, complex details spread across such a wide area requires incredibly steady air and excellent viewing conditions. If conditions are right, you'll spot the external factor driving all this complexity: a yellowish companion dwarf galaxy, NGC 5195, on the right arm. There is an active gravitational tug-of-war happening right now between this smaller companion and the massive main spiral structure. As NGC 5195 pulls on the outer edges, it compresses massive amounts of gas within the Whirlpool's arms. This compression triggers rapid bursts of star formation. You can see the result in this high-contrast view. Those bright pink and red pockets scattered along the sweeping arms are entirely new star-forming regions. Because this dynamic interaction actively distorts the galaxy, the lighting is uneven and chaotic. It rules out any chance of capturing perfect mirror image symmetry. Dedicating your observation time to M51 means you sacrifice neat, high-contrast symmetry for the chance to capture the raw mechanics of galactic evolution. Now let's shift to M104. On our chart, it plots directly into the edge-on global symmetry quadrant. Looking at this wide shot, you see its extreme tilt relative to Earth. It creates the classic silhouette that gives the Sombrero galaxy its name. The major trade-off of this orientation is immediate. You lose the top-down mechanics, and the internal spiral arms are completely obscured. But in this close-up, you see what compensates for that loss. A remarkably thick, sharp lane of dark cosmic dust cuts horizontally across the center. That dark ring is far from empty space. It physically houses most of the galaxy's cold gas and its active star-forming material. Right behind that cold dust lane sits an unusually large, highly luminous central bulge. This massive, bulbous core glows intensely with the combined light of billions of old, mature stars. The immense concentration of mature starlight creates a brilliant, dramatic halo radiating far above and below the galactic plane. While you won't find the vivid pink starbursts of M51, stacking that pitch-black dust lane directly against the glowing core produces massive visual contrast. Targeting M104 trades an understanding of the galaxy's internal engine for a striking, immediate visual impact. Declaring one of these galaxies more beautiful is impossible. A successful viewing session depends entirely on matching the target's physical structure to your specific goals. We can use this decision tree to align your priority with the right cosmic target. Let's start at observation priority. If your absolute priority is documenting active cosmic events and complex structures, we follow the left branch down toward galactic mechanics and interaction. You need a face-on orientation. A grand design structure gives you intricate details spread across a wide field of view. That path leads directly to the Whirlpool galaxy. It is the definitive choice for deep sky photographers hunting for active starbirth. Alternatively, if you want stark aesthetics without needing pristine conditions to resolve faint mechanics, we follow the right branch toward high contrast and symmetry. An edge-on dust lane perfectly blocks out the visual noise, delivering a sharp silhouette against a bright background. That leads you to the Sombrero galaxy, the superior target for anyone seeking classic symmetry and a dramatic glowing halo. Ultimately, the title of Most Beautiful reflects which physical phenomena you value most at the eyepiece. The night sky doesn't reward random browsing. It rewards preparation and clear intention. Knowing the difference between face-on interaction and edge-on symmetry prevents you from wasting your precious hours in the dark. Explicitly aligning a galaxy's structural realities with your own observational goals is the only true way to master your time under the stars.